Okay, we're going to go over the graphing stories Desmos activity. Starting in the first slide. Okay, it says there's a lot going on in the video. What different measurements are changing in the video over time? So he's going up, so his distance from the ground is changing. So at first he was going away from the ground, then he paused. Now he's going back closer to the ground. And as well, the time was moving, right? We went 15 seconds. So distance from the ground is changing and time is changing. Sketch the relationship. So starting with, the y-axis is our height of the waist above the ground, and then the time in seconds is along the x-axis. So, and this is in meters. So each meter is about 3 feet. I'm going to assume that this guy is about 6 feet tall. So he starts out like right around here, and then he's going to go, well, I'm going to watch the video. That'll help me. So he goes up, 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 up to about, for 5 seconds until he's about, let's say, that's going to be 2 meters, so about 3 meters above the ground. So he starts here and then goes up to 3 meters over 5 seconds. It's not perfect, but it doesn't need to be. Okay, and then he kind of, so time goes on, but that distance stays the same until, when did he start going down the slide? 11, 12 was when he started going down. Yeah, so right around there. And then, yeah. So something like that. Again, it doesn't need to be perfect. Oh, I never even noticed there's lines there. That would make it a little neater. Let's try that instead. So he started like there, we said. And then between there and 5 seconds about, he got to, think about to here. So can I draw a line in between? I sure can. And then until 12 seconds, he stayed the same. Well, actually, let's go back again, because first he was standing, right? And then between 6 and 8 seconds, he sat down. So let me go back. Can I do undo? Yes. So until about here, and then he went down a bit. And then he sat there for a second until about 12 seconds, so more like 2 seconds he sat there. And then he went down. So yeah, something like that, I'm gonna say. Watch and answer. So he goes up, 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 and then drops down, and then goes over. And then, aha, he stands back up at the end. I missed that part. So now we're looking at a relationship between water in a bowl and then the time. So as we're watching, aha. So it's pretty constantly filling up. It seems, I mean, at a somewhat slow pace, but then that whole bit of water is added right there. So definitely starts with some water in there, and it's going up at a pretty constant speed or a constant pace until about 6 seconds. So let's say that, something like that. Whoa, that's not what I wanted. I wanted this. And then it goes up really quickly because we added a whole bunch of water. So for 1 second, it goes up much quicker. Let's say we added like a liter plus a little more. And then it continues filling up at a constant speed. So I want that same slope for the rest of the time. So something like that. All right, and then we'll check our answer. Oh no, they don't give us our answer. And then we'll go into number of eggs in a carton. So starting with, we start with 5, and then 1 was taken, and then 2, 3 were taken, so 2 are left. And then 1 more is taken, and then the last one is taken. So we're gonna end up at 0 just before the 15 seconds. 1 was taken, and then at 5 seconds, 6 seconds. So at 5 seconds, there's 4. 6 seconds, there was 3. Okay, go back. 12 seconds, and then 13 seconds. So 12 seconds, and then 13 seconds. So let's just connect those dots. There we go. Aha, distance from the camera and compared to seconds. Let's watch him. He goes away, so his distance increases and then decreases, and increases and then decreases, increases and decreases. Okay. And then he walks away. Okay. So I liked that, what I just did of kind of plotting my different points. So let's start over again. So he starts close. Let's say he's okay. Go back. And then at 3 seconds he comes around again. 6 seconds he comes around again. 10. And then here he starts walking away. Let's say this whole thing is about 1 meter. So when he's riding around, that furthest point, he's going to be about 1 meter away. So at 1 second, he's there. At 4 seconds, he's there. At 8 seconds, he's there. And then he stops. So at 1 second, he's 1 meter away. At 4 seconds, he's 1 meter away. And at 8 seconds, he's 1 meter away. And then, oops, that one shouldn't be there. Should it? No. I should take off that dot. Can I erase? I can. Erase. And here, let's see again. I hated these things as a little kid. My brother used to spin it really, really fast until I'd get sick. I'm close, and then at 11, he's back here, and then he walks away even more. So now let's go ahead and connect those dots. So it's going to go further away, closer, further away, closer, further away, and closer, further away, and then he walks away. Okay, now we're going to do another one. Going around, So center from the distance from the center of the carousel, this time, the distance from the center. Well, that remains constant the whole time, doesn't it? He's about, let's say, half a meter away until that point. So he's about half a meter away until right here, and then he starts walking away. Let's connect and connect. Okay, now we'll look at the answers. So this is for the water. So yeah, we're going up, just increasing pretty steadily, waiting for the internet to load. And then it goes way up, and then again, kind of evens back out to that constant rate. Now, the next one, the eggs in the carton. This starts with 5. What's happening? Aha, interesting. So it starts at 5 and then just drops right down to 4. And then drops down. So this is interesting because this is showing, right, these lines show us that it just goes straight from 5 to 4. We don't go in between 5 and 4. At no point in time do you have like 4.5 eggs. No, you go from 5 and then it drops down to 4. And we stay with just 4 for a while, and then it drops down to 3. Then drops down to 2. Then drops down to 1. Okay, and how about this one? Yeah, so distance from the camera. So I kind of had the right idea, but they were saying he was much. And he stopped and then walked away. Okay, how about this one? Distance from the center of the carousel. Oh, come on. Yeah, so again, it just stays, it remains constant because no matter where he's at moving around, he's always that same distance away from the center until he stops and then starts walking away. We don't need to do this part, that's all right. And that's it.